welcome to my channel where we talk about cool cars, cool technology, and alternative fuels. Welcome back to the solar panel system. This is revision 3.1 of the system, and it has a lot of upgrades and features I'm anxious to tell you about. But before we do that, I want to talk about what it's powering. It's powering a house. Revisions 1 and 2 powered an office, and this is powering a house. It was actually flooded during Harvey. During the reconstruction process, I got the opportunity to come in and install this system that you see before you today. Now, before we get into how it works and all the specifications, it is a work in progress. So, hence the wound up cables and the plethora of connections up top. So, please bear with me on that fact. Now, this system has a pure sine wave inverter. It's got inside the inverter, a charger, and the transfer switch. And this inverter is a certified inverter for off-grid and grid tie inverter systems. And since it has the transfer switches inside of it, that certification means that there's no chance of it's backfeeding the grid. And also, the electrical system in the house and the breaker box was wired by a certified electrician, so we're all good there as well. So we're safe on this system. Moving on to the overview of the system and how it works. Up top, we have a control box. Now, what the control box does is it measures different functions and outputs of the system to make sure everything's working right, and if something's not, it tries to correct that by maybe starting the generator if there's low power, or turning off the air conditioner in the house if there's a really big load somewhere else. It can do quite a few things, and it's got quite a few sensors and inputs on it. The box below that is the inverter. It's a pure sine wave inverter like I talked about before. It's got the charger and the transfer switches inside of it as well, but its main function is to do inverting, which is taking DC power from the batteries down low and turning that into AC power for the house. Now there's a wire on my head. This system normally uses power from the solar panels, which are above us, to power the batteries, which are charged up and then supply power to the inverter, that then supplies power to the house. That's the normal method of operation. If there's a problem, like the batteries get low, mentioned before, generator can kick on, or the system can call for the grid to kick in, and the inverter will actually turn into a charger, charge the batteries from the grid, and send power from the grid straight to the house as well. Now, the generator in this system is an inverter generator. It's not a real inverter generator from the standpoint of a normal style inverter generator. It's actually a generator outside and uses this inverter as the inverter part of that inverter generator. It's a 3-phase alternator. It's hooked up to about a 6 horsepower Honda clone engine, and that is then rectified, the power from that is rectified into DC at 48 volts. It's a 48 volt system, by the way. It's then sent into the battery pack and then up to the inverter and then out to the house. And what that does is, while it's electrically less efficient than directly sending power from the generator to the house, it allows me to vary the RPM of the generator up and down, much like an alternator in a car can vary the RPM can be varied up and down without changing the output voltage, just changing the output current. So when there's a low demand for power, the generator can throttle back. When there's a high demand, it can rev up when it's needed to kick on at all in the first place. This system has about 30 batteries here. We'll get into all the nitty-gritty specifications now. We've talked about all the basic functions of this system. So the batteries back here, there's Trojan T105 batteries and Trojan T875 batteries. The T105 batteries are 6-volt batteries, and the T875s are 8-volt. The 105s have a capacity of about 207 amp hours at the 20-hour rating, and the 875s have a capacity of about 170 amp hours at the 20-hour rating. Now, they're wired in series parallel configuration to get a pack voltage of 48 volts, which is the same voltage as the solar panels and the generator. The solar panels, there's 32 of them, 100 watts each, so 3200 watt system, and they're 12-volt panels that are wired together in packs of 4 to make 48 volts, and then wired in parallel to make a larger array of 48 volts with a higher current output. The generator outside puts out about 62.5 amps at full throttle, and that's also at 48 volts, and it can charge the batteries. Up here at the control box, there's actually 5 microcontrollers. They're ATmega 328P microcontrollers, same ones you find in Arduino Uno, and I have coded them myself to run this system. So each little microcontroller does a different aspect of controlling. One might measure battery voltage, one might measure the inverter output, and does all kinds of computing and really tries to, if there's a problem, correct it. Battery voltage low, do something. Start the generator, get the grid involved, or if the current output from the inverter is way too high, turn off the air conditioner to direct power to other places in the house where it's needed. It's really a system that can control all aspects, or controller that can control all aspects of the system in order to make sure there's always power going to the house, and to make sure that the 3 redundancies, the batteries with the solar panels, the generator, and the grid, are all functioning as efficiently as possible together. Now, this system is also set up to where if there is a failure outside of the immediate system, like in the grid, and the batteries are low, so it needed the grid, it can switch the generator, or if the generator has a problem, it can switch the grid. Now, it'll pick the most efficient one to use to start with, but if that one fails, it's got that extra redundancy on top of it, notwithstanding the solar panels and the batteries. So it's a very safe, reliable system, and very efficient as well, since it's all computer controlled. This box that you see right here is actually climate controlled as well. It's got a 500 watt air conditioner in the back, which helps to reduce the electrolyte evaporating in the batteries, and also keeps the temperature of the inverter down when it's running at a high load, and make sure that the processors don't overheat as well. So moving out to the generator, Predator 212 clone, and it drives a 3-phase generator, which is underneath this cowling right here. It's got its own control box on it, which does the choke and the throttle as commanded by the controllers inside. And at full power, the generator can provide about 62.5 amps of power, and of course at 48 volts. And that's sent through this cable here and the one down there, which is actually disconnected right now, into the battery compartment in here, and then to the inverter, and then ultimately to the house. So this generator is a special generator because it is the alternator that I mentioned, and with that, it's extremely efficient. This is about a 1 gallon tank. It's 0.9 gallon tank, and it can run on the 0.9 of a gallon. And this is with a cloudy day. The batteries are, dead. They've been used up. This thing will burn all day on that 0.9 gallon of fuel. So it'll run 12 hours powering this house on that 0.9 gallon of fuel. That's our top number. That's our record for running this thing. I think I've covered pretty much everything in the project. If you have any questions, just leave them in the comments and I'll be happy to answer them. Thank you so much for joining me today. Have a good day.